In this class, we'll talk about the standby 3V and 5V. This 5V actually works after triggering, while 3.3V has some in standby. This 5V is only available after trigger. This is a small difference between MacBooks and other laptops. In other words, although it is called 3V and 5V circuits in the standby state, in fact, it only has 3.3V in standby state. 3.3V is 5V. If standby circuit is broken, it will also call the laptop not boot. Its component is the same. What are the components? Here are the key ones. First, 3V large inductor. Second, 5V large inductor. Third, 3V upper and lower tubes Q. These are some of the main components. We will know those small resistors and capacitors. Fourth, 5V upper and lower tubes is mainly a QMOS. Fifth, standby IC, also called the main power supply IC and system power supply IC. Here, the standby IC is also relatively easy to break. When we analyze the 3V standby circuit, it focuses to analyze the standby IC. How does it work? The working principle of its standby IC is that it controls the conduction of the upper and lower tubes. Generate 3.3V and 5V from the 8.6V of the public point on the large inductor. Our analysis of the standby 3V and 5V is equivalent to the analyzing the standby IC. This circuit is easy to break, that is, the upper and lower tubes and the IC. So how does it work for the follow-up? We will talk about this circuit analysis later. Take you to analyze how it works and its general principles. If 3V and 5V are broken, it will also cause our laptop not boot. Then it is relatively simple to repair. As long as there are drawing, our handwork is more exquisite. We can easily repair this easily broken circuit. It is not difficult for beginners. Then we will lead everyone through the circuit diagram to analyze standby IC. How does standby IC control the upper and lower tubes to connect, and the working principle of the generating 3V and 5V voltage. Okay, let's go through the circuit diagram now. To analyze the working principle of the 3V and 5V standby state, let's take a look. There is U7201 in the middle, which is standby IC. Look at this L7220, what is it? It is a large inductor. Here is marked 5V, which is a 5V large inductor. Q7220 is 5V upper and lower tube. Then look at the other side. L7260, it is marked with the 3.3 volt, which means the 3.3 volt large inductor. Okay, Q7260 is 3 volt upper and lower tube. This circuit relies on U7201 to control the conduction of these two tubes. To complete a process of generating 3 volt and 5 volt. The tip of the upper tube is at 8.6 volt voltage generated by the public point. This 8.6 volt is from a public point, including outside. First, the 8.6 volt voltage generated by the public point. In other words, when measured here, it should be 8.6 volt. If there is no 8.6 volt, then there is a problem with the circuit in front of the public point. This sign is generated by the public point. What was this circuit before it worked? The public point must send the electricity to the depot of the upper tube. The power supply including this tube is also generated by the public point. It is a protective isolation circuit, which is produced by a circuit of the protective isolation circuit mentioned in the previous lesson. Then this mode here, the G pole is the square wave. The first pin of the upper tube is the G pole. The sixth pin of the lower tube is the G pole, which is a square wave. These two tubes are connected circuit in turn. If there is no oscilloscope, you can only use the substitution method to measure it. Then the generation of the square wave is completed by the standby IC. The standby IC is the key. So if there is no square wave in the G pole, then we have to check this standby IC, some of its key signals and circuits. So what kinds of key voltage point does the IC need? Let's take a look. First of all, we have to zoom in. The first key test point VIN pin is the pin of the power supply. It comes from 8.6 volt, which is the first critical working condition. It is not seen from the diagram that it is a voltage coming from a public point. In other words, if there is no 8.6 volt, look at the C720 on this picture. The probability of being broken is very high. It may be caused by the leakage or the short circuit problems. These capacitors must be checked. U7201 is the first test point. What about the second test point? With this signal, the IC also has a switch signal EN. This is the second working condition. It's 3.3 volt, which comes in here. If there is no 3.3 volt, find the upper level components. With this power, there are two voltage stabilizer outputs inside the IC. This stabilizer output and this stabilizer output on the drawing. These two stabilizers are the third step. This is 5 volt. If these two voltages are no output, then what has happened to this IC? After having this voltage, the standby IC will output the reference voltage. This fourth step is generally about 2.0 volt. If this voltage is not available, then we have to change our power supply IC. Right here, it receives a EN switch signal through a 3 volt. The switch signal passes from here. Take a look through the info resistor sent it to us. After this 3 volt switch signal, then the 4th and 5th steps. The 6th step, it receives the power supply. This VBST pin is the power supply of the driver inside, and it passes through an inflow resistor. It uses this square wave output to output a square wave at the switch pin through this capacitor. This capacitor is indispensable. This is our 6th step. This 3 volt is produced in the process. In other words, after this power is provided, it will output a square wave to the drip of the upper tube. Turn on the upper tube to charge the inductor. After the upper tube is connected, the lower tube is turned on again. The 8th step, 27 pins are for controlling the lower tube. 24 pins are the pins and control the upper tube. We send the GPO square wave of this tube out. The 2 tubes are connected in turn to generate the voltage of the inductor. How is this 3 volt produced? After the 2 tubes are connected, they are turned on in turn. The upper tube charges the inductor. Lower tube connect circuit. The power of the inductor discharges the load, which is called discharge. When it's working, the 2 tubes are connected in turn. This is a large inductor, L760 or 3 volt. When you measure it, it is 3 volt. If there is no 3 volt, you have to prepare the pieces of related circuit line and related components. There is a key pin here. After the IC word, if the 3+3 is normal, this PG signal is about to come out. PG is called the power good signal, which is also the PG signal. This is the last step, which is the 9th step. It should also be 3.3 volt. If this 3.3 volt is not valuable, to bad end, our rear pole power supply will not work. Let's take a look at the workflow of the circuit. First of all, we sort it out again. The common point first sends power to the depot of the upper tube 8.6 volt. This is the first step. At the same time, the voltage of the public point is also the first step, which is carried out at the same time. So here, after the IC receives power, it immediately receives an EN switch signal, 3.3 volt. After receiving the switch signal, its internal voltage stabilizer is the 3rd step. 29 pin and 22 pin send out 5 volt and 3.3 volt respectively. The 4th step, it will send out a reference voltage of 2 volt out. In this position, the 3rd pin, if these voltages are not available, we also need to change our standby IC. This is standby IC we are talking about, standby IC. So after this, we follow. The EN2 pin of the IC receives a switch signal. 3.3 volt comes through this side, we will chase. If there is no 3.3 volt, follow the source to find if the upper layer of the component is damaged. When receiving the switch signal, at this time the IC switch 2 pin also outputs a square wave control the capacitor at pin 25. capacitor C7264 and resistor R7264 to power our VBST pin. The C7264 capacitor cannot be less. R7264 this insurance resistor also can be less. These two components are also easily damaged, so pay attention. Then the 7th step is followed by 24 pin. Output square wave to control the upper two to turn on to charge our inductor. The internal upper two of the C7260 is connected to charge it. Then the upper tube will turn on when the load needs to power. The upper tube is cut off and the lower tube starts to output a square wave guide. Put the inductor's electricity to the load, forms a closed loop. This circuit then is workflow. Then 3.3 volt can be measured through this inductor. When the voltage is stable, the 20 pin of the IC output the good signal of 3.3 volt to send to our next layer of circuit. It means that the 3.3 volt is worked down. So here, everyone look at 5 volt. 5 volt is after the trigger. But its principle is the same. It also resists EM1 pin 5 volt switch. Let's take a look at the 5 volt switching signal. If 5 volt is not available, the switch signal must be received. After we resist a switch signal, it outputs a square wave. If there is no 5 volt, this is a 5 volt switch. Then with this switch, it will output this square wave. This is the second step. Output square wave control capacitor C7224 and R7245 resistors. Provide voltage to our VBST pin. The third step, the generation of 5 volt. The output square wave on the first pin to the G pole of the upper tube. This is our fourth step. The upper tube is turned on to charge the corresponding inductor. After fully charged, the lower tube starts to connect again. This is 30 pin DLVR1. Not the same time, the two conducting in turn. Release it when it is full, charging it when it is released. It must be full, not always filled and released. Then the fifth step. It is also a square wave. After this IC start working here, charging and discharging have been working. Charging and discharging the load. L7220 is 5 volt inductor. The principle of discharge of the 5 volt is the same, relying the conduction of the lower tube. Discharge the lower tube from a loop, so after the module works here, there is also a picco inside, and then the outputs a good signal to 3.3 volt. All power grid are 3.3 volt, which is the default. Whether it's an Apple MacBook or a Windows computer, it's the same. All the output from our PWM IC. The only difference is that the 3 volt is standby. So here it means that this is a working principle of the entire standby. Its components, let's take a look at the step and detect it. The circuit is easy to break during maintenance. Check carefully and measure its corresponding voltage with a multimeter. Okay, that's it. This is circuit principle analysis. Next, let's talk about how it's repaired. Okay, let's take a look at the 3 volt and 5 volt. During maintenance, there is no voltage on the inductor. How to repair it? I have been standby for a few days. Our standby 3.3V no voltage maintenance method. The method is the same. Check the resistance of the inductor to the ground first. It has several situations. In the first case, resistance value less than 30 is called short-circuited. It is not necessarily 0. As long as it is less than 30, it is special. 3V and 5V inductor. Its diode value cannot be less than 30. Less than 30 is short circuit. Other power supply inductor. It is called short circuit when it returns to 0. Keep this value in mind, it's easy to confuse. Less than 30 is called short circuit. In the second case, the resistance value is in OL state, which is called open line. In the third case, resistance value is 300 to 800, which is access. This method is the same as the maintenance method of the public point, and they also use the burn-in method. Connecting the line from 3V large inductor. Slowly increase the voltage of the power supply from 0V to 3.3V. There are two clips. The power clip is clamped on the wire. The positive pole is clamped on the wire, and the negative pole is clamped on the earth wire of the motherboard. Then go back to our explanation of the third step. Slowly increase the voltage. Adjust from 0V to 3.3V. Adjust and fluctuate at the same time. See which IC has heat. Capacitor heating can be deducted without installing. Replace the IC directly if it gets hot. So here from the maintenance experience, what is the general cause of the 3V short circuit? Remember, either is a standby IC, which accounts for the majority. Either it is a capacitor of the load. Either EC or bridge PCH. If the capacitor is good, 80% of the problem with the standby IC are bridge and EC. On the current motherboard, the bridge has been integrated into the CPU. Either it is to synthesize a bridge, so focus on few points. There is only one bridge on the current motherboard, and even the bridges of some motherboard are combined with the CPU. So we have to replace the CPU. If you found that there is no bridge on this motherboard, it is inside the CPU, you need to replace the CPU. If there is an independent bridge, just replace it. It can be repaired if it is broken, but the cost is relatively high. The CPU needs to be replaced inside the CPU. This is how to repair short circuit. How do we repair it? Open circuit is relatively simple to repair, the cost of the open circuit. Why this whiteboard? Generally, open circuit is whether there is a disconnect between the common point and the depot of the upper tube. If the wire is disconnected, need making jumper for it. If there is no disconnection, it is possible that upper tube has burned. Then replace upper tube if burned. The second is that the IC itself is broken. Replace upper tube. In other words, there are only 3 cases of the open circuit in terms of experience, including what we have summed out in maintenance. Either there is a disconnection between the public point and the depot of the upper tube, either the tube itself is damaged and the upper tube needs to be replaced, either the standby IC is broken. Next, we are going to talk about the repair. We have to look up the drawing to repair. Then the third is connect circuit, resistance value about 700. There is no voltage on its inductor when it connect circuit. Generally speaking, either the IC is broken. The probability of the large inductor being damaged on the laptop is very low. The cause of no voltage in the line or the standby IC is broken. Change the standby IC first. If there is any problem, if the standby IC is broken and it is not good, then open the drawing to check the IC. Open the standby IC diagram. Check its key pin. Which pin position should be focused on to check? Remember here. When I told you to analyze just now, I also saw it on the picture. The standby IC has several pins. If this is a standby IC, here is the VIN pin, 90 volt. If there is no 8.6 volt voltage, look for the related components. In addition to the 8.6 volt, there is a signal EN. EN switch signal 303 volt. Come in these related components. NREG5 and NREG3. One of these two voltages is 5 volt and the other is 303 volt. First of all, there is no power in these two. If these two of power are not available, change the IC, first in and out. After this, there is an RF voltage, which is translated as a reference voltage. It is generally around 2.0 volt. You have to check these key components. And also whether our EN1 and EN2 303 volt has been received. Find the key components of the upper level if you haven't received it. Assuming you don't have 303, if you want to find it, just search through the drawing. Which one of the above points can be used to find the corresponding file? That is to say, when the standby IC is not good for connecting circuit. There is also a key pin VBST. The components of the pin should also be checked. This is called critical situation pin. During maintenance, we focus on these pins. When the IC is not good, these pins are key to check. So whether it is 5 volt abnormal or 3 volt abnormal, the investigation is carried out according to the ideas. First, open the resistance value, check the condition of the IC. These are the some maintenance methods. The only difference is that our 8.Macbook 3 volt is available in standby. The 5 volt comes out after the trigger. The repair method is the same. Okay, this is our 3 volt and 5 volt repair method.